Okay, so the next question, that is simple but a very tricky question I'm going to discuss today. So what is this question explaining? Let us see here. The field lines of the two charges are shown in the figure. Determine the ratio of Q1 by Q2. So what is this ratio Q1 by Q2? It's very simple here. Okay, so it's a very tricky question. First of all, count the field lines surrounding Q1. The field lines surrounding Q1 are 12. The field lines surrounding Q2 are 4. Therefore, the solution is Q1 by Q2 can be taken as 12 by 4. Therefore, that is 3. 3 is your answer. Okay. So, the charge Q2 is negative. Okay. So, the charge Q2 is negative, whereas the charge Q1 is positive. Okay, so how can you say? Because wherever there is a positive charge, the lines of force are divergent. Divergent means move away from the center, and the lines of charge near Q2 are convergent. That means they meet at certain point here. Okay, these are convergent lines, these are divergent lines. Therefore, Q1 is considered to be positive and Q2 is considered to be negative here. This is positive and this is going to be the negative charge. It is understood. It's a very simple question, but we won't get an idea that we have to count the field lines. Okay, you know that the greater is the density of the field lines, the greater will be the electric field strength. Okay, so this is the final conclusion here. Thank you very much. Hi students, these are the simple but a very tricky questions today I'm going to discuss today. So let us discuss the first question, which is a little bit tricky. It seems to be very easy but little bit tricky question it is. So let us solve this question here. So what is this question? First try to read and understand this question here. A charge Q is placed at the middle. There are the two large charges Q, capital Q and capital Q. A middle charge, a small q, is kept here at the middle exactly. If the distance between the two charges is taken as L, okay, so the question is like this. Find minimum value of charge capital Q from the options given here. So how are you going to find out the minimum value of charge Q here? Okay, so it is given that E is the charge on the electron, and the four options given as follows here. The first option is given as E, second option is given as 2E, third option is given as 4E, and fourth option is given as 8E. So we have to find out the value of Q here. How are you going to find out the value of Q? How much is the value of capital Q here? Is it Q, is it E, 2E, 4E or 8E? So this is the question here. So how are you going to find out? It is said that a small charge Q is placed in between the two large charges in such a way that the total system is at equilibrium. Then how are you going to find out the charge capital Q here? For that, it is understood that the force between the small charge and larger charge will be the sum of these two, that is force due to capital Q and small q. This is the force between these two charges, and force between these two charges, the sum of them will be equal to 0 because the system is at equilibrium position here. Hope you have understood this one. Okay, the force between these two charges and the force between these two charges will be almost at equilibrium if you add them. So that's what we have written here. So therefore, force Q, capital Q and small q is equal to minus of force between capital Q and capital Q here. So what are you going to do now? The force between these two is written as K, capital Q, small q by L by 2 whole square here, and the force between these two large charges can be taken as minus q minus k capital Q divided by L square. Here K is constant. You know the value of K here. It can be written as 1 by 4 pi epsilon naught here. So what are you going to do? So cancel out these two. Cancel out these two. So we're getting how much here? That is small q by L square by 4 is equal to minus of capital Q by L square. Here L square is also getting cancelled. Then ultimately you're getting minus q is equal to, this comes to the numerator, 4 comes to the numerator, it is going to become 4q. Okay, so what is the minimum value of small q? What might be the minimum value of small q here? So small q can be E here, which is the minimum value, minimum charge. Okay, and that is charge on the electron if you consider here. Therefore you can write now capital Q is equal to minus 4 into E. Okay, so irrespective of magnitude, irrespective of the sign here, if you consider, you can write the answer as 4E. So our correct option is going to become 4E here. It appears to be very simple, but it's a very tricky question, because we are not going to get an idea that we have to take a small q as E as the minimum charge possible here. That's the new and surprising thing. Okay, so that's the answer. That is capital Q is going to become 4 times of small e here. That is the answer. Third option is going to be the correct answer. So this type of next tricky question we'll discuss here. Then the next page.